It's okay. I think you can see my screen.
Yes, we can. And I know you haven't forgotten, but before you joined, there were a lot of calls for you to not forget the quick recap of yesterday that you promised us.
I heard the last person saying something like that. So I'm going to do well to ensure we.
Fantastic.
Okay.
Good. All right.
Yes. So we will not waste time. We'll just start. My network has been terrible. I just hope it's going to be stable throughout this 1 hour, 30 minutes session. But no big deal. Let's see how far we can go. All right. Yesterday, we looked at, I am Jeremiah Agada. Sorry if I have to do introduction again. I'm Jeremiah Agada, the CEO of Peniloa Educational Consult. We do data analysis and we consult for researchers. We are into research, active life science research also. So like we said yesterday, we looked at statistical tools and analytical tools at the same time. We looked at data cleaning. Now, quickly, I'm going to look at certain things on this. If you look at my screen, the screen I'm sharing now, you will see that my data is looking somehow. From here, where you can see variety, that's varieties, rather, you see moisture, you see ash content, oil content, protein content, crude fiber, all of them in percentage, and then carbohydrates. Now, if you look at the data here, I'm going back to data cleaning. Then before we look, I'm just going to do a recap of what we did yesterday. I couldn't share the PowerPoint anyway up till now, but no big deal. Let's see how we can go. Now, this is an interface. This is an overview of SPSS. This is SPSS 16. At least yesterday we said we should have a way to install it so that we can use. I don't know if there is a way I can send it to us so that if those that have, I don't know if somebody can comment, those that have the SPSS package in their system, I will send you this raw, exactly this file, so that we can be doing things together. That's the aim. If you have, then fine, I'm going to send possibly to the general group, or I don't know if there's a way I can share here so that you can just download. We just have to do that so that you can see, but nonetheless, no big deal, we can still go ahead. Now, this is an interface, a general interface of SPSS. This is SPSS 16. A better one, if you have 20, version 20 or 25, and then I saw 28 of recent. They are improving it anyway, but this is 16 and it is user-friendly. Anybody can use this. You don't have to have the knowledge of statistics to be able to use this. Interestingly, it may surprise you that there are many statisticians, those that study statistics with degrees and PhD in statistics, that cannot use this package. So it is user-friendly if you pay attention to learning. Now, very importantly, yesterday I told us something about data cleaning, that you just prepare your data to use. The aim is just to prepare your data for your data to be analyzable, if you can use that word. Something that you can use to do something. Now look at my data. You see setting, like look at the moisture content here, the moisture in percentage. You see that the first one, a variety of rice. This is a research, somebody's research that we worked on. These are various varieties, improved varieties, that's genetically modified varieties of rice. They were checked, these contents, moisture, ash contents, oil, they were checked for. That's the approximate composition they were checked for, and then these are the results. Now, I told us something that if you want to really do data analysis, especially when you are doing a lab work, you want to really do analysis, you need your data in duplicate or triplicate, as the case may be. You need them at least more than one. So if you look at my variety, I just want to recap what we did yesterday. Now you see this variety 8321 18 is a variety of soya beans or maize. Sorry, it's a variety of maize. These are local maize. These are local maize down, but these ones that have tag, they are improve varieties. Now, if you look at this, you see 8321, 18, 8321, 18. So there are two. Now that means we had a variety, the same variety, but we had to check them at different points. So if you look at this, the moisture content, we had 4.13. Then we had the second one, 4.139, which is approximately 4.14, if you are approximating. Now, ash content, you have 2.73, 2.72, 8.43, 8.42, like that. So you have double, so that you can be able to determine the mean of the of that particular rice. Now, if you look at this very well, this is for rice. If you are looking at my cursor, this is for rice. This is for soya beans. This is this is farro. Farro is rice. TGX is soya beans. And then this is maize. I'm just trying to remember the result. It's been a while we did this. So if you look at this, for the maize, we had two different proximate composition testing results. That means there were two samples for that maize. So for moisture, we had two results. For ash, we had two results. The same thing for soya beans, and then for rice, the same thing, two results for each of them. It is with these that you can now be able to do anything that you want to do. Now that is one. So you need duplicate, except if you are using questionnaire. With questionnaire, you are just looking at frequency and then percentage of percentage count, number of outcomes, like that. That's what questionnaire would do. I don't know if you have the time. I would have loved to, maybe tomorrow, although tomorrow we're looking at results, presentation, or discussion, how to discuss your results. Now, but in this case, having duplicate is one thing. Then the next thing is look at the number of decimal places that we have. Some are double, some others are even in whole number. Like for soya beans, come down to soya beans, you see under ash content, you see that it's just 5. 5 is something as 5.0. But you cannot take something like this because anyway, SPSS can still analyze it. But to clean your data, you can ask SPSS or leave the work in 2 decimal places. Then, if there is any missing data here, then of course you have to note it. Interestingly, SPSS would not accept to do any calculation, any determination of any analysis for you when you have missing data. We have to know that. So where it is missing, it has to be 0. Otherwise, you have to replace it. You must replace it. Or in a general sense, it will not just work. It won't calculate for you. Otherwise, you have some warnings and some error results. So if I want to, I'm joining many things together now. If I want to analyze, look at this result, SPSS, another way, does not recognize words. Does not recognize, it recognizes numbers. So I cannot say I want to do my analysis and then I'm trying to look at these independent variables because these ones are actually dependent on these ones. So these independent variables, this 832118, the varieties, they are independent, they are there already. So if I want to do any analysis, I have to convert all these ones to numbers. That means I have to code them. That's where coding comes into place. And that's part of the data cleaning too. You do your coding to make sure it is suitable for analysis. Now, if I have to do that, if you look at my interface, come down, you see data view. That is that is what will help you to see all these things we have been seeing and then we've been talking on. The data view will help you. Then if you go to variable view, that is where you will now see where you can manipulate your data or change certain things. All right, this is my variable view. Now, if you look at my data, if I had done anything on this work, it is obvious that I would have gotten error. I would have gotten error. Now, the reason is simple. Look at the types here, the names of the variety and then the various subheadings are taking this VVV. I'm going to close this, but as time goes on, I'm going to close this and reopen again to correct something. Now look at this string rather. Once you convert to number, it is obviously going to now be numeric. If you're looking at this, it's going to be numeric instead of string. If you use string, this is majorly non-parametric or qualitative kind of analysis where you just want to work with when you just want to work with maybe graphing or other kind of analysis. So in this case, we have to convert everything to numeric here to allow us have certain things. So let me just do that quickly. And then another thing again is where we had our decimal points. Now look at these decimals. These decimals here for my variety. Look at, I'll go back to my data view. Okay, you see many things has changed here already. I just touched this, the string there, and certain things has changed already. So look at the variety here. That's the V1, sorry. You see B015, it has changed already because I touched something. Okay, if I convert everything, I'm going to close this and open it again because the way it is not giving me what I want, but just look at what I'm doing and then I'll explain later. Okay. Then if you look at the width, maybe I may have to explain certain things also. If you look at the width here, you are seeing 12, 18, 18, 15, 18. This width just means the number of words or alphabet or numbers rather that that particular box can take. Like for the first one, it can take up to a count of 12. That's the V1. It can take up to a count of 12. The other one 18 and this one 16. Normally, I just need 3. But we can leave it like that. Then the decimals for the V, I don't need any decimal points, but these other ones, I need them to be in at least two decimal place or 4 decimal place. In mathematics, they advise you to use 4 decimal place when you're leaving your answers. So in this case, I would just like them to be in 2 decimal place. And then this one in 2 decimal place. Still part of the data cleaning, this part of preparing your data before we begin analysis. All right, so this is this. Then values. This value, it just means you are trying to replace. Okay, you are telling SPSS what each value, because I told you earlier on that SPSS does not recognize letters, so it recognizes numbers. Now in this case, where you have coded, you will tell SPSS and say, okay, for every 1 that you see here, it means this. 2 means this, 3 means this, and like that. So I want to do something. I'll go back to my variable view. I've converted this one out to 2 decimal place. Let's see what we're going to get there. All right. So look at my whole data now. The one that was 5 before, look at it here. This one was 5 before. Now it is 5.00. So it's now in 2 decimal place. So you see, it has transformed, or it has used the word cleaned. That's cleaned the data to now be like this. Now there is space here. You are seeing 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 space here. Data and SPSS would not do anything. When I was introducing this, I didn't highlight something. I think that will now help us. Let's go back. I want to introduce this again. Let me bring back this file. Now, when you are loading your file, I think that's another thing again to know. When you're uploading your file that you want to analyze, you will come to File. Those of us that have it already, if you're using your own, you'll come to File. You check Open, Data. When you check Data, you click on Data. I'm waiting for it. It's looking slow. Okay, so Then where you kept it in your system, you know where it is. So mine is on the desktop. And then how do you now see this interface is showing me something empty? That is because I don't have, look at these files of type. I don't have any SPSS saved data. That means what I have is in Excel. That's the idea. So I'm going to tell SPSS and say, okay, I want to have the opportunity to load a file that is in Excel format. So I'm going to touch this arrow or the middle, wherever, and then you now see you have a CStack, you have SPSS portal, you have Excel. So this is where I have my own in Excel. So as soon as I touch this, you'll see what will happen now. Fine, you have all this here. Now, I was looking at proximate analysis. I have all these are names of data file. So don't mind what you are seeing here. All right, so I have this. This is what I want to work on. I'm going to now touch it, and then I will open. Okay, so this is what we have. Okay, I have several sheets of data here. So I want to open the first one, and then now read variable names from the first row of data. If you don't check this one, it is going to give us the same kind of issue that we had. So if I check this, I'll say continue. I'm waiting for it. It's slow. Okay. Oh, it's still giving me what I had before. Okay, anyway, let me see if I can do something. Okay, now I've done something here. I removed that space that I was having before in the previous one. So that means I have to tell SPSS what my V1 is, what my V2 is, what my V3 is, what my V4 is, what my V5 is, and then V7, V6. Okay, so quickly, I'm going to now work on this data to make it analyzable. Like I said earlier on, so I'm starting all over.
Sorry, let's just be a little patient. We seem to have lost our resource person. Please, let's be patient. I'm sure he will join back again. Thank you. Sorry, I'll just prompt Mr. Gada to find out what's happening, but I'm sure it's his network. So please, let's just be a little more patient. Thank you. Yes, sorry, Egia and everybody else. I think the resource person, the network dropped him out. I'm trying to reach him now. Thank you for being patient. Absolutely, Dr. Sadebe, I love that suggestion. Thank you for drawing my attention to it, Choma. Sorry, Florence. Yes. So is there anybody here who can discuss what they have learned so far? Let me see if our own in-house data guru is here. Oh, he's here. You know, a goldfish has no hiding place. I'm putting you on the spot again. So, of course, you know, I'll call you Mr. Felix. So let me invite people to discuss what they have learned so far, as rightly suggested by Dr. Sadebe. And if there's anything somebody says that isn't quite correct, please point it out so we can have a robust discussion while we're waiting. Thank you. So I know Gospel has been participating actively, so let me call on you again. Gospel, are you still here? You are. So let me ask you to unmute. Unmute and let us know what have you learned so far. Thank you.
Oh, okay. Good morning, everyone. Can you hear me?
Yes, we can. Good morning again.
Okay. I've been actively following, and then though it would have been nice if my SPSS was installed, it would have been quite nice. But then I've been following theoretically, so I trust to do justice to that. After the class, I should be able to install it for tomorrow class starts.
Oh, okay. Yeah, but of all he has taught so far, is there anything you'd like to point out? Can you do a recap
From what? Yes. From
what has been taught? Yes, please. Yes, go ahead.
Okay, from what he has taught so far, I I've been able to understand that for first of all, for you to open the file, the software, you go to the file if you want to work with it, and then you look at where the SPSS is saved, either on the desktop or wherever you saved it on. Then if you want to work, now the page will be empty. You have to go to where you have the data. If it is in Excel and all of that, you open it, and then it says something about strength, that if you want to run it, you cannot at times you cannot run it on string. You have to perhaps change it to numeric. That's the language the SPSS understand. And I'm sorry, I'm still wrapping my head around it. But then, like I said, that that I feel while my SPSS is installed.
Okay, your voice trailed off for that last sentence. If you can just repeat what you said last.
Okay, I said it would have been nice that I followed it up if my SPSS was installed on my system. It would have been more active that way. Yes.
Okay. All right. Thank you. That part you said, yes, I heard that part too, but there was something else you said. What if you've entered data and the place is empty? There was something he said you should do. You didn't enter something when you were entering your data, so one column is empty. Column for one variable is empty. What did he say you could do?
Hello.
You think? Yes, please. Yes, please,
Okay.
Dr. Sadebe.
Okay, I thought he said if there is an empty column, that SPSS cannot work with an empty column.
Exactly.
That,
yes.
Yes. That when we are cleaning the data, we have to fill it up. Unfortunately, I didn't get what to fill it up with.
Okay, I think he said that if you do not have, let's assume you didn't, you don't have any data set to put in that place. He said you could just add 0 to that place.
Okay.
Yes, he's back now. Thank you. So we're not gossiping about in your absence. When the network dropped you out, we decided to have a discussion.
You need to pray for my network. My network is terrible. I don't know why the thing is season like this.
Okay, we're praying now. All right, go ahead.
Is that right? Thank you very much. So I just want, let me just put something so that we can go ahead. We don't have all the time. So here I have variable. If you observe, I think I learned something too. You learn every day. So if you observe, I put, I typed moisture space content. So it refused to accept that. It just needed one word. That's what I observed. So I had to leave moisture there. So I'm going to put protein here just to save time. Then we'll put oil. We'll put carbohydrate or maybe moisture. We have moisture already. Okay, let's put carbohydrate. Normally, then let's find another thing.
Put heat.
Pardon?
I say heat. Can heat go? H-E-A-T.
Okay, let's put heat. Okay, let's just put something, right? Okay, heat. Okay, then here let's put water. No big deal. So, but that's actually supposed to be the heading of your data. That's your dependent variables actually. All right. So the variable here is actually the independent variable. So we said our width. This width basically means that you are dealing with the number of numbers of the number count of figures that can enter that space. So here we can type up to 12 words or numbers. Yes. So here 18, just as the case is, but we just need what we have already. Now the place of decimals, I'm going to change this. I want this one to just be 0. And then I want this, you see, we cannot alter this. We cannot edit this. You know the reason? Because of this string. So because of this string, so I'm going to change everything. Remember, I did that before to numeric. I'll do the same thing here to numeric. Here to okay, numeric. Numeric. Okay, so we have this now. So I can change my decimals. My decimal here, I want it to just be 0 because it is actually telling us we are doing coding there. So here I just want 2 decimal place. Here I want 2 decimal place. 2 decimal place. You can just type if you don't want to touch the arrow. All right, then value. Now, quickly, let's just do this. For my variable view, I am going to go back now to my data view. I'll come back to data view. You see everything here has changed. Look at my heading now. I have variable, moisture, protein, oil. That's where we had V1, V2 to V7 the other time. So here now, I'm going to convert this now to 1, 1, 2, 2, 3. You know, they are replicates, so double, 4, 4, 5, 5, 6, 6. I think that is all. I'm seeing a decimal place here. Okay. Don't think we have. Okay, there's nothing there. Okay, I hope it doesn't. Okay, so I'm going to now replace what does 1 mean, what does 2 mean, what does 3 mean. So here I'm going to come to this the value under the variables. I want to now tell SPSS what each of those things mean. Normally, you are supposed to have a place where you are seeing and then you are typing or copying and pasting. You are supposed to have something like that. So here, my value, I have 1. What does 1 mean? You know, 1 mean a variety of maize, right? So I'm going to just put, since I cannot remember the coding now, the number there, I'm just going to put GMO or maize GMO. So I'm going to maize GMO. So add. So 2, what does 2 mean?
Sorry, just a minute. Sorry, if you have unmuted yourself, please mute. I don't know how that's even possible. Okay, so please, okay. Mr. Gada, there was a question. Somebody was requesting, if you don't have anything against it, if you can share your data set so he can work along with you whilst
that would be so. How do I share it? That's the problem. How do I share now?
Do you have it in like maybe Word form or something that you can input?
No. I have it in Excel form.
Yeah, so you can send it. Yes, you can send it.
Can I send it? Can I drop it on the national?
Yes, please. Yes, I prefer it there. Yes, as PDF.
Okay. So let me just drop it there while I'm also doing this. Let's see if we can do many things at the same time. So I have the second one is soybean.
Right, thank you.
All right, man. Okay. Oh, I cannot share it to author aid. I'm not an admin. So let me just send it to Dr. Zainab. So I think she can drop it there for us.
Sure, please do. Thank you.
Yes, I'm sending it now to you directly. Okay, I've done that. It has entered.
Good. All right. Thank you. I'll share it now.
You're welcome. Okay. So, okay, I have that. I've put that of rice. So now the next one is local variety now. So I'll just say maize. So, sorry. So 4 now will now be local maize. 5 will be possibly local soybean. And then 6 will be local rice. Okay, if you see now, there's a
Okay, so we're having another network glitch. But let's be a little patient. Even with all the difficulties, I'm sure you're all enjoying the workshop like I am. So let's just be a little patient. You'll log back in. Thank you. But in the meantime, let's see who I can put on the spot to answer some questions so far. So we had a man in the last one. So this time, the first lady, at least from the name, Aisha Shitu. What have you learned so far? Whilst we're waiting for Mr. Gada to join back. Or Ebele, did you want to say something? Good. Aisha Shitu, except if there's a volunteer.
Sorry, I just heard my name, my own net. Is it my own Ebele? Good morning.
Yes, good morning. So what did you learn? So we can discuss.
Oh, okay, so far?
Yes, please.
Okay, what I could get from the whole lecture so far, Dr. Jeremiah is trying to lead us on how to cleanse data that we've collected. Okay, so he was trying to like pull us through on how to go about it. He started by telling us even when you want to pull data that is already stored in Excel, and then you want to use SPSS. I think the software he's using this morning is SPSS. So if you have your data already stored in Excel, and then you want to transfer your data to SPSS. So he was trying to explain to us that during the trying to import from Excel, now when you get to like file, I think he said file data and all of that, that you realize that when you get to the point of trying to import the data, you will realize that the interface at that SPSS is empty. It's because the data you want to import is not stored in SPSS. So you need to change the SPSS to Excel. Now, once you do that, you will see all the data that is already stored in Excel. Then you now choose the file you want to import. Now, when you import, you have to go through the process of cleansing your data, making sure that all the decimal points, maybe you decide on what you want actually. If you want to 2 decimal points, you have to change it. Then if you want, and he pointed out that your dependent variables must be numeric, which of course you need to have changed all those ones at the, is it data phase or variable phase, where you have strings and all of that. So you need to change all of them to numeric, that SPSS will not take your dependent variable if they are categorical. So you need to go there, all the strings, whatever, you change all of them to numeric, so that by the time you get to your data view, everything is in order. So I think basically that's what I can say, but it was at the point of letting us know that the column where you have your variable name, if it's empty, is equally a problem, that you need to define your variable name. So that column must be filled up. So it was at that point that even me, the internet threw me off. So I didn't get what he was trying to say then. Even I was just entering when I heard my name. My internet too is not stable, so but I'm just waiting to learn more.
If you learned so much after the internet threw you out, I think we should keep throwing you out. So thank you so much. Well done. I think you got a lot. So Mr. Jeremiah, he's back now. Please continue.
Okay, thank you.
So if you look at my data now, my data is from the interface, my data is ready for analysis now. So we can start analysis. Looking at my data, if you understand everything we have done from the beginning, you clean your data, make sure your data is good, the number of decimal places are the same, and then you have coded your independent variable. This is going to be the independent variable. And then all these other ones are in place. Now, the next thing you want to do, look at this data. What do you now do with this data? Sometimes you don't have to look at objective to know what you want to do. From your data, okay, somebody went to the lab or somebody went to the market, got genetically modified organism, food, variety of food. Most times in Nigeria, it is not available in the market to see. It's not available. We checked in Kaduna, most of the supermarkets here, we didn't get them. So I can categorically say it is not available, but there's nothing that's not possible. So somebody goes to the farm and then he engineered a particular species of crop, and then he went to the lab to do proximate analysis, and here we have a result. Now, he has GMO for rice, for maize, for soybean, and then he is trying to compare with that of the local varieties, local maize, local rice, and then local soybean. Now, the question is, looking at this data, the first thing I want to do, I want to see a descriptive of this. I want to see a kind of summary of these data. Now, they are in pairs. I want them to be in simple mean form. I want their mean to come out. And then possibly, I want to know if there is a significant difference between each of others. The moisture content in rice, is it the same with that of soybean? The moisture content in soybean, is it the same with that of maize? I want to know. So I am curious as a data analyst with my plenty data that I have. There are more data. Sometimes if I have another set of data that is, if you look at it, you'll be surprised. You cannot find the beginning. Possibly you can see the beginning, but you not see the end. So much big data. So you look at something like that, you want to check the summary of it or the descriptive. Now, simple. I'm going to go to, sorry, I want to remove.
Okay, so whilst you're doing that, I just need to announce again that please, everybody should try to fill the attendance. We've been posting the link since, and we'll keep posting them at intervals. We'll keep posting the link at intervals. So please try to fill the attendance. Thank you. We have about 62 people, 68 people in class right now, and we have less than 20 people who have signed the attendance. Thank you so much. Please go ahead, Mr. Agada.
Okay, thank you very much. Now, if you look at your interface, you will see file. You know what your file is supposed to be meant for, to bring in, to import, to export, to save, and whatever. Then edit and other things like that. Now, this place where you have data is where you can do some measures of data cleaning also. And then you can transform your data. But where I'm going to is the analytical part, the analysis aspect. So if you look at analyze, for those that have access to SPSS now, if you look at analyze, you will see reports. Then under the report, you will see case summary. Now, case summary will obviously give you a descriptive. It's going to show you the summary of the data you have. Now, come to descriptive also, you will see frequencies. It is going to show you descriptive again, crosstab, ratio, PP plot, and QQ plot. All those ones are going to tell you, show a plot of the data that you have. So let's do the descriptive first before I say something. I'll touch descriptive. Now, what kind of descriptive do I want to do? There's a problem here already. Now, just pardon me. Let me just check something. Compare mean, one way, ANOVA. All right. So now back. If you look at your analyze, you will see under the descriptive, if you touch descriptive, let's do it quickly. I'll copy everything here, or better still, let me just copy what is these other ones. These ones you can highlight, you can just be tapping, and this arrow is meant to send them in here. So if you highlight everything, you can send all of them at once. So you don't have problem with that. Then this option is going to give you opportunity to say, okay, I want mean, I want standard deviation or standard error, I want variance, I want range. Then your level of distribution, you want to see whether this your data is evenly distributed or they are not distributed. So that's the essence for these Q2Cs and skewness. Then how do you want it to display? Do you want it to be in alphabetical order? You want it to be in variable list? Variable list is better. Ascending order or descending order. If you follow any other way, you may have your data scattered. So it's better you allow it in variable list the way you have already outlined them in the table. So I'm going to say continue, and then I'll say okay. Okay. So we'll see a result. What do we have here? Okay, still coming. Okay, so we have this now. This is our descriptive statistics here now. So if you look at this, our number of entry, we have 12 for moisture. You understand what this 12 mean? Let's go back to, I'm going to close this. And then, okay, if you look at this, if you count the variable, they said it's 12. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 rows down the column. That's the idea, 12 rows down the column. So everything is showing the same. So let me bring back the result so that we can look at it. Okay. Can we see this? Please, can we see this? Uh-oh.
Sorry, no, we can't. Oh,
can you see this one, descriptive statistics? Can you see this one I'm sharing now?
We can see the table, yes.
Okay, that's just what I want
us to see. That shows very
now.
I just brought it back. That's why I'm asking if we can see it. Okay, so now if you look at this, you have.
But this hand is up.
Pardon?
Okay, let's see. Okay, I have the chat box open.
Somebody's hand is up.
Let's see who it is. Okay, there's Adamu Usman Aliu. Let me unmute you so you can ask your question. Adamu, I've asked you to unmute. Somebody says we can't see the output window, but I can see the screen. I don't know what part you want
if you
to
can see. If you can see this table, that's what I want you to see for now.
Can you just roll your cursor over the entire table so that we'll do
this?
So that they'll be very sure that is the same thing we're talking about.
This one.
Yes.
This one.
Can you can you run your cursor from oil to carbohydrate to heat to water so that they'll know that is the same thing we're talking about? I can see it, but can you?
Okay, I'm coming. Let me just move. Something else. Okay. Okay. Can we see everything? Moisture, protein, oil, carbohydrates, heat, water,
yes.
then valid n list-wise. Okay, if you can see, then that's water. Yes.
It stops at water on my screen.
Okay. Oh. Let me see if
can you scroll to the right? That'll be to the right now, right?
My system is not giving me room to do that here.
But
anyway, if you have up to water, that's what you need. You don't need them, but the valid n is telling you this is still giving you a summary like total. So we don't need that. We don't need that now.
All right then.
Okay, so this one now is giving us minimum value, maximum value, and then mean. What I need is mean and standard deviation. Most times I'll tell you that most presentation when you are publishing papers, you want to use standard error than standard deviation. The reason is because the standard deviation, the values for standard deviation used to be very high most times. So, and you don't want somebody to look at your data and then go to your standard deviation or standard error and see that you have a large value of error. Look at my own. The value here is terrible. I have 8.74. It is too big. It's too large to give that kind of room for mistake. And then I have 10.00, 11.98. It is too large to allow in a simple research like this. So that means there's a problem with this result. That's the meaning. But no problem, we want to just continue our analysis. Now, this is just a descriptive. Now, let's say we want to now check whether there is significant difference between or among the various means. Now, what I'm going to do is I'm going to go back. You can continue from here. This is your output view, but you can continue from here. And then I will check, analyze, compare means, one-way ANOVA. You see, you can do your pair sample t-test, your independent sample t-test here. So I'm taking one-way ANOVA. So one-way ANOVA now. This is where you also need to know what you are doing. Now, you know, your data is divided into various categories of variables. Now, you have the dependent and the independent. You know your dependent variable, you know your independent variable. Your dependent variable is that variable that relies on another variable, while the independent variable is that one that influences other variables. So in this case, my variety should be my independent variable. So in SPSS, it is going to now be called the factor. You put it there in the factor. And then all these other ones, I'm going to highlight them. Your Control A will still work. So I'll highlight them, or you take them one by one, and then you move them here. So I'll just touch this arrow and all of them are there. So I am now checking my factor with my dependent variables here. So in this case, the first thing you want to also, another thing rather you want to do is you want to check your post hoc. Now, you know, yesterday I said your sample size matters a lot. Your sample size. If you have sample size greater than from 30 and above, Duncan is good to use, is the best to use to separate your means. When you are separating means, I'll show you how to separate now. Then if you have less than 30, you use LSD, you use Tukey, you use Bonferroni, and many others. You see many of them now. So I'm going to check post hoc. I'll tap post hoc, and then you see LSD. LSD compares means against others. So LSD.
Sorry, I think your screen is freezing.
My screen?
Yes, because we're not, I'm assuming we're supposed to see where the analysis has been done. But what we're seeing is, for example, under 6 underwater is 64.18. Is that what we're supposed to be seeing?
Underwater.
Yes, that.
I've not done any analysis now.
Okay. So we're supposed to be seeing, excuse me. So for example, 12, row 12, under variability 6, and water for that 12 is 64.18. That's what we're supposed to be seeing.
I cannot even see the 64.18.
The last underwater, the last variable at the very bottom, that is on row 12. I don't want to keep you too long, so we don't.
Sorry, let me just see if I can.
6418. Is there?
Pardon?
6418.
Yes, is there now?
64.18. There used to be something for.
Is it? But okay, is it this one?
Okay, yes.
Is it this?
Yes.
I'm not. Oh, this is where you are seeing. Is this what you are seeing?
Yes, this is the screen we're seeing.
Okay.
We just want to make sure that's what we're supposed to be seeing.
Oh, sorry. You mean I've been talking since and you people were not seeing what I was doing? That means I didn't share that one. So sorry about that, please.
No problem.
So let me now share what I have been doing since.
There are so many hands up. Can they be given opportunity to ask their questions?
Okay, I was thinking, okay, all right, let me just allow one person, somebody whose hand was up first, at least I saw first. Adamu Usman Aliyu. So I'm going to allow
but before the person asks, can we see this one now?
Yes, I can see this.
So that means I have to start all over again. No problem.
So Adamu Usman Aliyu.
Let's get the question.
Adamu Usman, okay, is he still there or has he gone? I've asked you to unmute. Is that what you wanted to see?
Hello, good morning.
Morning, how are you?
Good morning.
I'm fine, and I hope everybody is doing good.
Yes,
we are good.
Thank you. Let's be fast. Thank you.
Okay, sorry, it's not a question. I just want to say it's today that I'm allowed to join this. So I'm very, very sorry for the late. I'm sorry for that. That's what I'm going to say. It's not a question.
Oh, okay, all right. Thank you so much. All right. So we'll send you a recording. You'll be able to get a recording. So just keep your eyes on the forum. Thank you so much.
Okay.
All right. So briefly,
much.
just Kosakop, is your question? Quickly, we've lost enough time.
Yeah. Good morning, everyone.
Morning, how are you? Please make it fast.
I'm fine. Now, I just want to quickly clarify in terms of data cleaning, where we have a missing data and we put 0, wouldn't that affect the average of what we are determining? That's just my curiosity. Thank you very much.
All right, thank you so much. So I'm thinking he will address that as we go. Thank you. So Mr. Gada, did you get that? So
yes, I did.
Thank you very much. So let's carry on. Thank you.
Okay. When it comes to data cleaning, you see, I was saying that you cannot do analysis with missing data in your interface, your data view, if you want to do analysis on SPSS. So to save yourself and to allow the whole thing to continue, you have to put 0. But you know, literally, as a researcher, that if you put 0 there, literally you are altering your result. So you have to fill in that result. In data cleaning, of course, you have identified that there are missing values there. You have identified that there are spots that are empty. So you have to replace them. There is a technique for replacing. There is a way of doing that. But in this case, for us to go ahead, I said we have to have 0. That's the idea. Is that okay? So please just understand, you just have to put 0 so that you can go ahead with analysis. But if you want a true result, you can't use 0. You have to find what is supposed to be there. Or better still, you do multiple imputation analysis. So you have to impute that data. You can ask the software, statistical software you're using, to do it for you. And it's very simple to do. So now, since we can see this, I'm going to check analyze. I want to do ANOVA quickly. Analyze, compare means, one-way ANOVA, if you can see this, one-way ANOVA. Then my variable is going to be my factor because it is the independent. Then these other ones are going to be my dependent variable. But I cannot just analyze like that to get one-way ANOVA. I want many other things. And that is where you are going to see some other things in the descriptive. So I'm going to touch post hoc. This is where I stopped, where I thought we were following all. Now I'm going to touch LS, the least significance difference. Born-Ferrari, I'm going to put as many as possible, but you see that some of them are going to be repetition of themselves. So Born-Ferrari, I'm going to take 2 key. I'm going to take Duncan. I told you when your sample size is more than 30, that's when you need Duncan. But I want to take Duncan because you're going to see values. It's going to give you also something. Then others also, they will help you to check for some of these things. Then, okay, look at my significance level. At what significance level? That was what I was talking about yesterday. 95% confidence interval, 99%, depending on what you are doing. So my significance level here is 0.05. Remember, I said yesterday that when your level of significance is less than or equal to 0.05, your difference, your mean difference is there's a significant difference. But if it is greater than 0.05, there is no significant difference. So here, because I am using 95% confidence interval, the 0.05 means out of 95%, out of 95 of 100, you have 5. So 5 divided by 100 is going to give you 0.05. So that's what it means. So we are looking at the margin of error margin. That's what we're looking at. So if it's greater than 0.05, it means that there's no significant difference. That's the meaning. So I'm going to continue here. And then I have option also, you see. Now in the option area, I'll say, okay, I need descriptive. I want SPSS to give me descriptive here. Then all these ones, fixed random effect, homogeneity of variance test, Brown, whatever, all those ones, they are also options that you can also take when you want. But for ANOVA, you don't need them. Even the descriptive, you don't need it. But I want, instead of going to do descriptive or case summary before you now come to do ANOVA, you can escape that. Just come to ANOVA, tell ANOVA will do descriptive. Even when you want to do chi-square, you can tell the SPSS to give you your descriptive also. So you can escape that one and just go ahead with this one. So mean plot, you want it to plot to show you whether the means, the numbers, that your data is evenly collected. That's the essence of that. So you can check that. And then how do you want it to be? Should it be case-wise or analysis by analysis? Most times you can take analysis by analysis. You can take list-wise to just list all your results for you. But most times analysis by analysis is better. So I'm going to say continue. So if it's going to continue, I'll say okay. And let's wait for our results to come. Good. So our result is here. Look at this place. Just like in geography, this is going to be like a key that connects us. So I want to see my descriptive first. I'll tap descriptive, and then it's going to show me my descriptive. So if you now observe, you see, from my data view in the first place, from my data view, you observe that it was 1, 2, 3, 4, like that I had. But here, I have replaced them now with other things. Let me go down so that we can see this. Okay. This is actually the descriptive I was looking for. Okay, can we see this? This is my descriptive. So for moisture, under moisture, you know it is moisture, then protein, then oil, then carbohydrate, we added heat, and then we added water. So now for moisture, we have maize GMO, soybean GMO, rice GMO, local maize, and others like that. Now, the number of variable, the sample size I have for each of them, they are 2. They were just replicated. So then the mean value is this. These are the mean. These are the mean that we have. And then you have your standard deviation and standard error. Now, interestingly, look at my standard error, 0.005, 0.00. Why is it 0.007? So any of them can go. You can use any of them now because your standard error, the possibility of error while collecting your data is very, very, very insignificant. Is insignificant, very small. So in this case, we don't need this upper and lower bound. We don't need minimum and maximum. You know what minimum and maximum is? Your data, which one is larger, which one is smaller. That's what it just means for maize under moisture. You know, there are 2. So one must be big, the other one will be small, as simple as that. So all we need now is just your mean, your standard deviation or standard error, one of the 2, and then it goes for others. Now, if you look at the whole thing like this, look at our mean. Our mean for maize is 4.13 or 4.14 if you're approximating to 2 decimal place, 4.14. So if you have something like this, you know obviously that comparing the moisture of maize and moisture in maize and that of soybean, you know that you have more water content in maize than in soybean. As simple as that. But how do you now know that there is a significant difference among these means or between the means? You have to come down now to ANOVA. I'm going to go down now to ANOVA. This is ANOVA. And then from ANOVA, we have our moisture now. Now look at moisture. We have protein, we have oil, carbohydrate, heat, and water. Now for moisture, our significant difference is 0.00, 0.000 rather. All of them are 0.000. Now, from the understanding that when your level, your p-value, level of significance is less than or equal to 0.05, there is a significant difference. When it is greater than 0.05, there is no significant difference. So that means that among the means that were collected for moisture, for protein, for oil, for carbohydrates, here in this case, there is significant difference among them. There's significant difference among them. Then, if you come down to post hoc, now let's look at post hoc quickly. I'm just trying to, okay. You see many things came out here. You have moisture. For moisture, you have Tukey. If you go down, you see Bonferrari, you see Duncan. I put many of them, so you just need one of them. So for maize GMO, I'm seeing something here. Okay. Anyway, this one now is showing us a kind of descriptive, just like we had done for like we did for ANOVA. So you have maize GMO, soybean GMO. You have standard error 0.0300, which is different from the one is in the descriptive. That one was 0.005, and then your significant difference here is 0.00. There's something I'm looking for. Let me just go down and see if I can get. Okay. So this one now is is helping us now to separate the means. If we know that these means are significantly different, that means the moisture content you get in the GMO for maize is not the same as the one you got in GMO for soybean or GMO rice. So that means they are different. So how do you now separate the means? That's the idea. How do you now separate the means? It's as simple as look at local soybean. That's for carbohydrates. Now we're separating for carbohydrates. Now, the carbohydrate content in local soybean, rice, local maize, and then others. You see now here in this case, it has rearranged it. So you have to have a way. Sometimes you look at somebody's results, and then what you are seeing is you are seeing some superscript A, B, C. This is where you can get it. Now, it is ranging from this point. If you look at it very well, the higher number or the highest number is here, then followed by this one, followed by this, if you can see my cursor, followed by this and by this. Now, 39.99, if you're approximating to 2 decimal place, 39.99 is higher than 10.35. So in that case, if you are separating the mean, soybean GMO, because it is higher, it is going to carry a superscript of A, the mean value of soybean GMO for carbohydrate, or the carbohydrate content in soybean is going to carry a superscript of A. Then maize GMO will carry B. Then if you look at it again, local rice will also carry B. So that means there is no significant difference between the carbohydrate content in maize GMO and local rice, if you understand what I'm showing here. So because they are in the same category, to say they are under 4. So if this is A, this will be B, this will be B. Then this will be C, this will be D, and this will be E. So you have said that's where under you now say different superscript or different alphabets shows significant difference, or shows that means are not the same, are significantly different at p-value less than or equal to 0.05. So in this case, you have separated that of carbohydrate. So if we go forward, or go upward rather, we'll see, okay, this one, some of them just came together. We have Tukey and Duncan. So here you have for protein, Tukey, and now let's compare the both of them. They're even doing the same thing. So Tukey is giving us the same separation with Duncan. If you look at it very well, local soybean is going to be A here because the mean value is 5.05. Then soybean GMO is going to be B if you are comparing all of them together. Normally, you can just do your comparison for just among the GMOs and then among the local. Then later you can now do a grand comparison of everything together. So this will be A, this will be B, this will be C, this is going to be D, this is also going to be D. That is rice GMO will be D, then local maize also will be D. That means the same content, their means are the same. The mean for rice GMO and the mean for local maize, they are the same here. And then the last one, which is going to be A, B, C, D, E. The last one, which is going to be E, is going to be local rice if you are separating. If you look at Tukey, is the same thing, the same way of separation. So sometimes there will exist differences. At other times, you will see that they are the same. So in this case, they are the same. There are some cases where you will have A, B. I want to check if I can see something like that. Oh, all of them are not, they are not overlapping. Okay, just accept this one in this case where you have A, B, B, C, C, sorry, C, D, and E. Do we understand what I'm saying here? Hello? Hello?
Sorry, they're responding yes in the chat box. There was too much interference, so I had to wield my big stick. I'm not allowing them to unmute, but they can say yes, they can hear you. Yes, you can hear, but do you understand? Everybody's saying yes, yes, but yes, you can hear, but did you understand what he said? Somebody said yes, but can we have examples of overlapping? Good. That's not the only person. Shoma too wants to know. Yes. Can you just briefly go over overlapping? Yes.
Okay, that's fine. Okay, the case of overlapping, let me see if I can. Let me bring another data, please. Let me just bring another data. But this one, I'm not going to do some cleanings, kind of, so that we can be fast. Our time is fast spent. It's already 11:30.
Yes, it's already 11:30. So we can quickly do something, get round off, and then.
Okay. Let's leave that idea of overlapping for now. Maybe I'll show that tomorrow. I'll just keep that as one of the things I'm going to do tomorrow with the last thing. Tomorrow's work is going to be very, very simple and straightforward. It's just interpretation of results. So I'll do that tomorrow. So, but for now, please, let me just quickly look at another thing. Now, we have looked at ANOVA. You can also look at other things like the correlation and regression. This is regression. You can do regression. I said regression, you want to check several dependent variables with, several independent variables with a single dependent variable. So when you are trying to see whether the dependent variable or the dependent variables are affected or they influence that dependent variable, you use regression to check. So we can run regression, we can do correlation, Pearson correlation. So we can do correlation, and then there are others like the t-test. Let's just do the t-test quickly, comparing means. T-test. Let me move this from here. I have something that's covering. Okay, so I'm going to one sample. Let me do one sample t-test. So let's now check something. Although I'm seeing something also, there's an error somewhere in my data. The data were not well collected or arranged before analysis, but no problem. This is moisture. I want to now compare moisture and protein. I want to compare moisture and protein. Is there a significant difference? I'm doing t-test now, testing the both of them. Is there a significant difference between them? So in this case, I'm going to check option. You see, I'm doing t-test. So the confidence interval is 95% confidence interval, and then it's going to be case by case analysis. Okay. Let me just say okay, and let's see what result will come out. Okay. Okay. Can we see the result here? I believe we can. So this for moisture now is giving is now look at the results that we have here. We have for moisture, we have 11.84. What does that mean? It's a grand total. So all the moisture received for soybean, local and the genetically modified, rice, local and genetically modified, all the moisture that we have, all the moisture content, we join them together and got the mean 11.85 in 2 decimal place. And then for protein also 2.69. Now, if you look at we want to now see one sample, what happens at the end of the day? Is there a significant difference? According to SPSS here now, we have look at the significance 0.001 and 0.000. So the result here is showing a significant difference. If you're comparing, there's a significant difference in this case. I cannot. Okay, so we have this as the significant difference, which is a high significant difference. You know when it is less than or equal to 0.05 or when it is greater than 0.05. So with this, you can do as many analyses as you want to do. If you have the SPSS package in your system, you can run as many analyses as you want to, different kind of analysis. There are many things you can do here. These are just the ones that anybody, like the person that asked a question yesterday, he sent a mail, and then I said I want to see the data. The idea is simple. Your ANOVA, we have done ANOVA, and then a simple t-test. You can run a t-test.
Excuse me, Jeremiah. Hello, excuse me, Jerry.
Yes, ma, I can hear you, ma.
Hello.
Yes,
Yeah,
I can
please
hear you.
let Eddie Young ask his question. His hand has been up.
Okay.
Hello, Eddie Young.
He has not unmuted. He's still muted. He's mute, rather.
Okay. Admin, please, can you unmute him so that he can ask his question? I can't see who is the admin. Who is the admin? Okay, I'm a co-host now. Okay, let me unmute you. Wow. You can unmute yourself, can't you? I can't see your name. That's my problem now. Please unmute yourself if you can.
Otherwise, you can just type a chat.
Hello, Felix, can you?
Let me check the chat.
Okay. Okay, I can see the name now. Next to mute. Okay, you can unmute yourself now.
Hello.
Okay,
hello,
Eddie Young, if you can't unmute, okay, you can unmute yourself now. Okay, ask your question, yeah.
Please, my question is directed to the resource person. Hello.
Yes, we can hear you.
Okay.
Okay, sir. I'm working on work on anti-inflammatory of a leaf extract on Visa rats. So we have been finding it very difficult to get that particular leaf, and I don't know if I can send you the work so that you can tell us the common name of that particular leaf.
I'm not a botanist. But I have friends that are in Ahmadu Bello University in the botany lab, or the herbarium rather, the herbarium. I think they should be able to do it. So I can send to them. But it may take time. You know, this is December, and work will be starting next year. So we can do that later. If you have my contact, you can just chat me up and we can discuss.
Okay, you can as well. Hello. Edion.
Yes, ma'am, I'm hearing you. Yes, ma'am. Yes, ma'am.
Yeah, you can as well put the name of the leaf in the chat.
Yes.
Not this Zoom chat, in the general platform. There are many of us from different universities. Maybe we can be able to help you. Okay. Okay. Jerry, can we go back to the lecture?
Okay, we are rounding off.
Oh, another person wants to ask.
Yeah, I saw one Ebele.
Another person wants to ask a question. Okay, that's very good. Ebele, please ask your question. Hello, Ebele, let me unmute you. Ask your question. You can unmute yourself now.
Okay. Thank you once again. My own question is simple, is to the resource person, just for clarification. I want to find out the difference, because in manuscript, we see a lot of things happening there and the way people present their results. But
Yes.
I'm always so worried and I want to be on the right track.
Yes.
When you say you want to do a binary logistic regression, my own understanding is that your independent variable, you have two possible outcomes. Let's say I adherent, for instance, adherent, not adherent. And then you're looking at the multiple dependent variables that will obviously affect that dependent variables. But I'm finding it a little bit difficult to understand when you say you do multivariate regression analysis. And some people, which one is the right one? Because you see different. People will say they did multivariate analysis. Some people will call it multivariable analysis. So I want to just for you to just clarify this. I know it has nothing to do with, well, it has some, but we're not doing it now. But I just need that clarification. Thank you.
Okay. The idea is simple. There's the man over, although you are talking about the regression now, but when somebody is saying multivariable is just English. There is there is no tool, no serious tool that you will call and say it is multivariable or multivariate. But at the end of the day, the aim is you are analyzing several variables at the same time. That's why it is multivariate. Is that okay? So it is not, you cannot see that on SPSS. You cannot see that. If you check your SPSS, I want to just open quickly. If you can see my screen, you will see, okay, look at univariate, you see multivariate, right? Can you see this?
Yes.
Okay, so if you can see,
yes, we're seeing yes.
Okay, if you can see multivariate, if I touch multivariate analysis, I am trying to now do a grand total, look, this is my screen now. I'm trying to now do a grand comparison of the variables that I have. So my fixed factor is my variable. I'm going to put it here. Then all dependent are these ones. I'll send them here. So by the time you are doing anything, all these ones, let me just bring out a result quickly. Now, by the time you are running, you are bringing your result is, okay, this is what you should be getting. I want to quickly show us what the result will now be like. Okay. Now, this is the multivariate test. At the end of the day, is there a significant difference across all the various variables that I just tested? Now, most times, the Wilks lambda is said to be near accurate. So my level of significance is 0.00. In this case, there is a significant difference among all. I just did a grand check. So if you are doing the same thing, multivariate regression analysis, it is also going to give you something like this. So at the end of it is just name multivariable, multivariate. It is just the way the person possibly saw it in some, most times for everybody's publication or presentation, somebody must have checked another person's work, how the person presented. You feel, okay, this is the best way, and then you take the way the person presented it. So it is just the choice of word there, but the application is the same. Is that okay, Mai? I don't know if you get me.
Hello, Bella, are you okay?
She has gone off.
Hello, Bella. Okay, maybe we have lost her.
Okay,
there are two other hands up. Okay, two other hands are up. Uchechi.
Yeah, Dr. Uchechi, we are waiting.
Uchechi, are you there? I don't know if she has been unmuted.
Yes, she just sent a text.
Dr. Uchechi. Okay. Let me, okay, she can unmute herself now.
Yes, ma'am, I've
Okay.
done that.
Dr. Chechi, can you speak? Okay. Okay.
Good morning, Mr. Agada.
Yes, you're welcome.
You know, I actually imported the data you sent through the AutoAid platform, and I've been trying to, work alongside with what you're doing. I've been able to import the data, but it seems I'm not getting the same results you have. I've not been able to analyze my own data. I don't know where I went wrong. I don't know if I can do that personally with you.
Sorry, please, can you start all over again? I didn't get.
Okay. Can you hear me now?
Yes, go ahead.
Okay.
Yes, I can hear you.
I imported the data you sent to us through the AutoAid platform, and I was trying to work along.
Okay.
Yes, after putting in the data in the SPSS platform I have here, though it's IBM 20,
Yeah.
I've not been able to get the results you have. I was able to analyze my own data.
You couldn't get the results I got?
Yes,
okay.
I was not able to
there may be.
my...
Okay, you were not able to analyze it.
Yes. I don't know where I went wrong.
Okay, did you work? Did you check your variable view and
yes,
then convert it from strings to numeric?
Yes, I did, sir.
Okay, if you did, then it should work normally. But another thing again is my own result may be different from yours in this case. Now look at this multivariate test, the one on my screen, the one I'm sharing now. If you look at this, Wix lambda under the F value, you have 8.075 exponential 8. So this means 0.0000 in 7 places, then 0.75. You understand? So you will be seeing 0.00000 something. But in this case, this one has approximated or is presenting it in standard form. So that's another thing. It's very possible.
I don't know if I'll be able to share my screen with you later on.
Okay, fine. Just screenshot, just screenshot, and possibly on WhatsApp we can just look at it.
Okay.
Yes.
Thank you, sir.
You're welcome.
All right. So thank you so much, everybody. I don't think we should prolong this further any longer. As we always do for our online journal clubs, we usually do 1 hour on Zoom, and then we take the discussion to the WhatsApp platform. So please, I'm imploring everybody, please no unnecessary post, because if you post anything unnecessary, then it distracts from what we're discussing. Please, I beg of you. So we'll just take the discussion to the WhatsApp forum now. Thank you. I'm aware that there's some people here who are not on the WhatsApp, on the National Hub WhatsApp forum. So I'll just discuss with my team if it's okay to let those who are not within the niche for which this AutoAid National Research Hub Nigeria is, those outside the niche, if we can allow them into the forum for the purpose of discussion. But unfortunately, we're probably not going to be able to accommodate you for all the plans for which the primary aim of the SIP grant was for. Thank you so much. So if you could just hold on with the questions for about 5 minutes. Once I clarify with my team, I will open up the group and then post what the resolution is. Thank you. I know that James Zulu, yes, he's from Zambia. I know he's on our journal club group. So what will happen is, James Zulu, if you could just send me a private message in about 5 minutes, if you don't see any notification to say you've been allowed to join the group so that the discussion can flow. Thank you so much. So again, on behalf of the entire AutoAid National Research Hub Nigeria, all the coordinators, we want to say a huge thank you to our resource person, Mr. Jeremiah, who is also a member of the Hub, by the way, and everybody for attending. The attendance has been really impressive. Thank you. At one point, we were 72. So thank you so much. So without further ado, please just give us a few minutes. I'm going to close the group. Once we resolve, we're going to allow everybody in. Then I'll post I'll put whatever it is that has been resolved on the group so that we can carry on with discussion. So thank you very much. Really grateful. We'll be saying bye-bye now. Thank you. We're going to let you have the recording. And again, reminder, the link is there. It has also been posted again in the chat box. If you haven't registered, please register your attendance at the workshop. The link is there before we close down. Thank you so much. I really appreciate everybody. Bye-bye. Thank you.